Hello everybody, welcome to Pre-calc, Unit 1, Day 4, Domain and Range. Today we're going to talk about how to find the domain, both algebraically and graphically, and also how to find the range. So first of all, what is domain? Domain is simply the set of inputs, or x values, that generate a set of outputs, or y values. So we're going to find it algebraically or analytically first. Given a radical function, set the radicand greater than or equal to 0 and solve. Answer is always an interval. The reason we do this, domain has to be the set of values that exist in a function. So if you remember from last year in Algebra 2, when you take the square root, you can't take the square root of negative numbers. So the only values that will work will be where this thing right here, whatever's under the radical, is greater than or equal to 0. So it's pretty easy. I like to use D for domain. We're going to set x plus 8 greater than or equal to 0, and you just solve this. So my domain for this function is going to be x is greater than or equal to negative 8. So what we're also going to do today is we're going to kind of back this up. Why is that true? Well, if you think graphically, what we've already talked about in this unit, that's going to move our square root graph left 8. So if you think about what that sketch looks like, left 8, there's negative 8, here's a square root function. So you can see why our domain is going to be greater than or equal to negative 8. Okay, let's move on. Given a rational function, we're going to set the denominator equal to 0, or I like to say not equal to 0, because if we want to find the domain, we're going to find all the numbers that work. So the numbers that won't work are where that denominator does not equal 0. So again, we're going to take just what's in the denominator and say, well, that doesn't equal 0, and that's going to be our domain. All right, so our domain is going to be where x squared minus 4x minus 12 does not equal 0. So let's see, let's factor this. X minus 6, x plus 2 does not equal 0. So x cannot equal 6, and it cannot equal negative 2. Now, I just don't want to leave that as my answer, because those are the only two values that do not work in the domain. So what I'm going to do is I'm going to say my domain, x is an element of all the reals, comma, x does not equal negative 2 or 6. And that's a better way to write that. So if our function does not have a square root and it does not have a denominator with a variable in it, almost all the other ones have a domain of x is an element of all the reals. Okay, so you can write it like that, or you can write it as x is an element of all the reals. So that would be like your quadratics, your linears, cubics. If you do not see the square root, or you do not see an x in the denominator, you're just going to say the domain is going to be all the reals. All right, so let's practice a couple. Let's find the domain of the function algebraically and then check some graphically. I'm not going to check every single one. So what do we notice first here? We notice that we have a square root. So I'm going to say whatever's underneath has got to be greater than or equal to 0. All right, so again, we're finding domain. X minus 3 is greater than or equal to 0. Pretty easy to solve. My domain is going to be x is greater than or equal to 3. So this one's kind of easy to check graphically. Let's see what happens. So if you remember back to your transformations, you see a minus 3 inside that function. That's going to mean right 3. So if I go right 3, and it's a square root graph, it's going to look like this. So my domain is going to be greater than or equal to 3. See, those are all the x values that exist in this function. All right, let's move on to the next page. So now, what do I notice here? I notice that I've got a fraction and I've got variables in the bottom of that fraction. So that cannot equal 0. So my domain is going to be x squared minus 7x plus 12 does not equal 0. All right, I'm just going to factor this. Let's see, signs are same, both negative, so I get x minus 4, x minus 3. So basically, x cannot equal positive 4 or 3. And to turn this into a domain statement, I'm going to say x is an element of all the reals, except x does not equal 3 or 4. I'm not going to take the time to graph this, but a few words. You don't know how to graph this by hand yet, but if you were to throw this into the calculator, you're going to notice you're going to have asymptotes at x equals 3 and x equals 4. So therefore, those are not part of the domain. Okay, our next one. Well, what do we have here? We have absolute value. Well, absolute value is not a square root, and absolute value is not part of a fraction. So what we said was, well, if I don't have the square root and I don't have a fraction where I have an x in the denominator, my domain is simply going to be x is an element of all the reals. Well, that kind of makes this one easy. This one I think we could take a second to graph. All right, plus 9, that means left 9. So left 9, that's going to be negative 9. And it's a square root graph. Well, what's a square root graph look like? It looks like a V. So now you can see our domain, it's the set of all x values. Well, it goes this way forever, it goes that way forever, it includes that point. So basically it includes the entire x-axis or all the x values. That's why our domain is x is an element of all the reals. All right, our next example here. What do we notice? Square root. All right, so what I'm going to do is I'm going to take what's underneath and say that's got to be greater than or equal to 0 to find my domain. All right, domain is going to be 49 minus x squared is greater than or equal to 0. This one's not so easy. So if I factor this, I'm going to get 7 plus x, 7 minus x is greater than or equal to 0. So what do we get here for two values? I get a negative 7 and I get a 7, but what does that represent? Those represent critical values on a number line. So let's say I've got a negative 7 there and I've got a 7 there. What I need to do is I need to determine where this function is greater than or equal to 0. Well, we have to come up with a plus-minus line. So this might be a little bit different than what you learned last year. What I need to do is I need to determine where this function is positive or negative. So I'm going to test points. I'm going to test some point over here that's less than negative 7. I'm going to test some point in the middle that's between negative 7 and 7. You can make up any point you want. 0 is the easiest one to plug in. And then over here, I'm going to test a point that's greater than 7. So you could test 9, you could test 15, you could test 100. It doesn't matter. It just has to be some value on this side of 7. All right, so what do? What I do is I take a negative 10, I plug it into just this piece here, because this is what I'm actually testing. If you get a positive, you write a positive up here. If you get a negative, you put a negative up there. All right, so what happens when I take a negative 10 and put it in here? Well, be careful. Negative 10 squared is positive 100. So then I have 49 minus 100. Now, I don't care what the exact value is. I just know that that's going to be negative. So this piece of the number line here is negative. If I now take a 0 and plug it in here, well, I get 49 minus 0. That's going to be positive. If I then take this 10 and plug it in here, I get 49 minus 100. That's going to be negative. So now, what we want is we want the interval, because notice this says greater than or equal to 0, so I want the positive piece. I want this. And because it says or equal to, you also want those two values there. So this is the piece of the number line we want. Remember, this just represents what the domain is. So now how do you write that as a domain? Well, you have negative 7 is less than or equal to x is less than or equal to 7. Now again, you don't know how to graph this by hand, but if you were to throw this into the calculator, you're going to get something that kind of looks like this. Negative 7, 7, 7 on the y-axis, and basically you get a half circle. So if you think about the x values that are defined in this function, it's going to be all of these and only those. So between negative 7 and 7 inclusive, and that's how you write that interval. Our next example is very interesting because you're going to notice something here when you take a look at this. So first glance, you notice we have a fraction, and you see the denominator, and you say, oh, well, that can't equal 0. So all I need to do is I need to take that x squared plus 16, say, well, that can't equal 0. And I'm just going to solve this. Well, to solve this, you might subtract 16 from both sides, get x squared equals negative 16, and then ask yourself, well, I'm just going to take the square root now, and I'm going to get plus or minus, but then you realize, oh, the square root of negative 16 is 4i. Well, 4i is an imaginary number, okay? So if you solve this and you end up with imaginary or no roots, you're going to say your domain is simply x is an element of all the reals. And the reason for that is because there are no numbers that are undefined in this expression. Because if you take a look here, you're going to square your input. So no matter what type of number you put in for x and then square it, it's always going to be a positive. So you end up with a positive plus 16 is always going to give you a positive. So there's no numbers that could possibly make that expression 0. So your domain is simply x is an element of all the reals. And again, I know you're not familiar with how to graph this, but if you just throw that into the calculator, you get kind of a goofy graph that sort of looks like this. And you'll notice, again, the entire set of x's are represented. There are no breaks, no asymptotes. It goes left forever, goes right forever, so from negative infinity to positive infinity is covered. That's why its domain is x is an element of all the reals. All right, let's try one more. This one's a little tricky, okay, because it combines two things. Number one is part of a fraction. So you might think, oh, if it's part of the denominator of a fraction, rather, it can't equal 0. But you also notice it's got a square root. So you're asking yourself, well, hey, if it's a square root, what's underneath has got to be greater than or equal to 0. So we have to combine does not equal 0 with greater than or equal to 0. And what happens then is what's under the radical has to be greater than 0. It can't be 0 because it's in the denominator. It's got to be greater than 0 because it's underneath the radical. So we're simply going to set x plus 3, again, we're finding the domain, greater than 0. Well, this one's pretty easy. Domain's going to be x is greater than negative 3. Okay, let's take a look at domain and range graphically. So if you're given a picture of a function or a relation and you want to determine its domain, domain is always determined left to right. All right, so this would be domain, and it's always determined left to right. This would be the range, and it's always determined bottom to top. So you can see here we've got a visual. If my function starts here, notice that's a closed circle, so it doesn't, no arrow, and it goes this way, and then it goes this way forever. My domain starts here and would be all of these x values. All right, so for this particular function, that looks like my domain is going to be x is greater than or equal to negative 5. My range would be all the y values. So this is the uppermost value, and then the function goes this way forever. So my range, I use r, and we're going to use y for the range, is going to be y is less than or equal to positive 5, because that is the upper value right there. Now, to find range, there's only one way we'll ever find range, and that is using our calculator. All right, what we're going to do is we'll plug these functions into the calculator, we'll find the maximum or the minimum, and we'll use that to determine the range. All right, so that's going to be key for us right here. We have to remember how to use the maximum and minimum keys on the calculator to determine that range. So our first example here, this one we don't even need a calculator for, pretty straightforward. Y equals absolute value of x. Well, there's no transformations. We're just going to make a quick sketch of this. Absolute value graph without any transformations. And I know that point right there is going to be my minimum. So I need to find domain, and I need to find range. Well, domain will be the set of x values. So think about what this does on the x-axis. It goes from negative infinity to positive infinity. So that's pretty easy. Domain, x is an element of all the reals. You could also determine that by looking here and say, well, hey, I don't have a square root, and it's not part of a fraction, so it's going to be all the reals. All right, next, the range will be the set of y values. So if you notice, the y values have a lowest point, and that's going to be 0, and then it could be anything above that. All right, so my range is going to be y is greater than or equal to 0. Let's take a look at another one. Y equals 2 over absolute value of x. All right, so this looks kind of like one of our inverse graphs. And if you remember what our inverse graphs look like, y equals 1 over x kind of looks like this. So what's going on here? Well, that's going to be a vertical stretch times 2. And what is the absolute value going to do? That's kind of interesting. I know what 2 over x is going to look like. Basically, it's going to be this one here, but it's going to be stretched upward and downward a little bit quicker. But what does the absolute value do? Well, the absolute value, if you think about it, takes negative numbers and makes them positive. So even though I'm putting in negative x values, so anything over here, negative x values, the y value is then going to be positive. So basically what it does is it takes this piece here and flips it up here. So it's going to look like that. So if I were to make a sketch of it, basically going to look like this. So what would the domain be and what would the range be? Well, it looks like it goes to negative infinity here, and it looks like it goes to positive infinity here. But this is an asymptote. So in my domain, it can't be this value, but it can be all of these here, and it can be all of those there. So basically, the best way to write that would be x is an element of all the reals, comma, x does not equal 0. Now, you could also use a couple intervals, x is less than 0 and x is greater than 0. That would also be acceptable. This is probably the easiest way to write it. So for our range, all right, our range will be our y values. So it looks like it goes up forever to positive infinity, but does not hit this or go below it. So for our range, we're going to say y is greater than 0. Okay. Next one, square root graph of x squared plus 4. Again, this one here, you probably would not be expected to graph this on your own without a calculator. So I want you to throw that into your calculator right now and take a look at the picture. You can pause this video. I'm going to go on and show you what that sketch is going to look like. So yeah, up to here, I've got something that kind of looks like this. So it sort of does look like a parabola that's shifted up to. So, domain. Well, we sort of talked about this algebraically, right? If you have x squared plus something, no matter what you plug in for x, this x squared is going to be positive. So you're taking a positive and you're adding 4. So no matter what, that's always going to be positive. So there are no numbers that would make this undefined. So we're going to say x is an element of all the reals. Looking at my graph, I can see that it hits this value here of 2 and goes up. So my range is going to be y is greater than or equal to 2. All right, our last one. Y equals negative x squared plus 9. I think this one we can do without a calculator. This right here means I'm going to shift this up 9. That right there means I'm going to reflect it in the x. So basically it's going to be a sad parabola turned upside down. Okay, so up 9, I got a sad parabola. Domain and range. So my domain will be all the x values, all right? Well, there are no breaks, right? It goes to positive infinity, goes to negative infinity. There's no breaks in between. So my domain is simply x is an element of all the reals. Again, what you could get from this, because no square root, no fraction, all the reals. The range. Looks like the maximum is 9, and it goes down to negative infinity. So the range is going to be y is less than or equal to 9. Okay, this concludes day 4. It's very important, though, guys, if you have any questions, please bring them to class when we have face-to-face time. As usual, don't hesitate to reach out, email, Brave Square, or ask some questions in class. Thanks for sticking with us, and we'll see you soon.